Hello, assalamu alaikum. Hello.
Hello, wa alaikum salam. How do you do?
Okay, alhamdulillah, I'm fine. And you? Can you hear me?
I'm good, alhamdulillah. Yes, I
Okay.
can hear you very clearly.
Okay, thank you. So basically today I will try to discuss about that change detection, how we can easily make the change detection and also calculated the transition area. Okay, so let's go over to this class. Just I simply share my screen and also start the recorded. Okay, so now can you see my screen?
And it is just yes, it's appear
Okay.
for me.
Okay, thank you. Okay, so okay, so now you can see here I already create a map, land use land cover classification map. So now here I can get the two time period map for LULC 2021 and LULC for 1991. Okay, so two time period map I already created in here. And how you can easily calculate the land use land cover classification map, we already discussed about that part. And today mainly I will try to discuss about that how you can easily make the change detection and also calculated the transition area. So here you can see we can already created the two time period land use land cover classification map. This map is for year of 2021 and this map for 1991. Okay, so this map was a 1991 and this map you can see 2021. Okay, so we can get the lot of build up area is increasing in year of 2021. Here you can see lot of build up area, road construction, all of the things will be increasing. And also you can see this is the map for 1991. Here we can find out only some build up region. Okay, and lot of this is the barren land and this is the vegetation and also this is the water body. We can find out for the 1991. Okay, and also you can see when I open the 2021, here I find out the lot of build up area in this region. So lot of build up area, it will be increasing. And okay, so now I just try to show you that what's the change detection, how you can easily perform the change detection using Google Earth Engine platform, and also calculated how much water body increasing, how much build up area will be increasing or decreasing. Okay, so this type of calculation we also try to discuss in this online training program. So I hope you can easily learn all of the things, how you can easily make the change detection and also make the calculated the area, how much area will be increasing or decreasing different time period. Okay, or calculated the transition zone area. So let's go. I simply open the code, try to show you the change detection. So mainly in this time we are performing the analysis using the Landsat image, you can see. So I also open the Landsat image, you can see. So this is the, okay. So here we can get the Landsat image 1991. So this is the image for Landsat 1991 for this region. Okay, and using this image, we can make the land use land cover classification map for 1991. Okay, this is the Landsat land use land cover classification map 1991. And also you can see the 2021. So this is the Landsat image for 2021. Okay, and using this Landsat image for 2021, we can create the land use land cover classification map for 2021. So it loaded. Okay, so you can see we can get the image look like this. Okay, and using the satellite images, we can easily make the land use land cover classification map for 2021. This is that map for 2001. And we also check the accuracy of this land use land cover classification map, such as we can find out the accuracy look like this. You can see this map accuracy is that 94% overall accuracy, and kappa coefficient accuracy is that 92%. Okay, so now I just try to show you that how you can easily make the change detection using the 2 time period image for 1991 and 2021. Okay, so let's go. So just I simply write the comment, suppose change detection. Okay, so mainly for the change detection, first of all we need to reclassify all of those class. So in this time I need to reclassify all of the class. You can see when I want to put here this turning point water, here I put the 0, then 1, then 2, then 3. Okay, for 1991, and 2021 for same 0, then 1, then 2, and then 3. In this time, this value I need to reclassify. Okay, so I need to reclassify this value from 0 to 3 to 1 to 4. So first step is that I need to reclassify from 0 to from 3 to 1 to 4. Okay, so I need to reclassify this class. So how I can do that? So it's very easy. So I take a variable, suppose this variable that before classes, and I simply call the before classified image. So mainly in this time you can see we can get the standard image for land use land cover for 2021 and 1991. So here 2021 is the after, okay, and 1991 is the before. Okay, so this is the before. Okay, 1991, this is the before. Okay, so in this time I can simply call this before image. So I simply call this classified land use land cover variable name. You can see, so classified, I simply copy this variable name. This is the before. Okay, and 2021 is the after. So just I simply paste here, and now I simply use a function. This function called the remap function. Okay, so mainly this remap function we're using from reclassify from 0 to 3 and then 1 to 4. Okay, so just I simply put here the 0. This is the water, then 1, then put here 2, then put here 3. And also now I reclassify 1, 2, 3, and 4. So in this time 0 will be 1, 1 will be 2, 2 will be 3, and 3 will be 4. So just I reclassify all of those class for 1991. So the same process I need to also apply. So after class, so take a variable, suppose after classes, and in this time after classes is that this land use land cover map 2021. Okay, so just I simply call this variable name of this land use land cover classification variable name. I simply call, so just simply copy this variable name and paste here. Okay, so in this time I also use the same code for remap function. So remap and put here this classified from 0, then 1, 2, 3, and it will be just 1, then 2, then 3, and 4. Okay, so first of all you can see I just reclassify. Okay, so now I just reclassify all of those classes. So now 0 is considered as a 1, 1 considered is the 2, 2 is the 3, and 3 is the 4. Okay, so just I reclassify so all of the class. So now I want to show you that show all changes areas. Okay, so show all changes areas between this time period from 1991 and 2021. Show all of the changes areas. So for that I simply suppose all changes areas For that, I simply take a variable. Suppose this variable name is that changed, and I simply call the after classes. Simply copy this variable name and paste here. And now I use a function, this function called the subtract function. Subtract with before class. Simply copy and paste. Okay. So now I just simply use here that n equal to 0. Okay. So now if you want, you can simply search here what is the meaning of the NEQ. So you can see mainly this is that function on an element wise basis returns 1 if the first value is not equal to the second. Okay. So now I just simply show the result in here. So just put here the map dot add layer and call the changed. Simply copy this variable name from here. And then I had the plated function. So I use this visualization for that mean 0 and 1 and max 1. 0 means there is the no change, 1 means there is the change. Okay. And then put here the color plated. So it's like as, so I put here this as white. White, there is the no change, and red, it means that change. Okay. And also put this layer name, suppose this is the change. Now click to the run. So now we can get show all changes, all of the class changes between this time period. So white color identify there is the no change, and 1 is the red. Red identify there is the change. You can check the result first. So it working, you can see at the new layer in here for the change. Okay. And this is the overall changes, all changes between this time period. Where this change it happened, it's showing the red color. And where there is the no change, it's showing as a white color. Okay. We can get the two class, changed and unchanged. Changed, red color identify changed, and white color identify there is the no changed. So it working. Okay. So now you can see here, this red color identify there is the changed, and white color identify there is the no changed. Okay. So we can get the overall change, show all changes. Okay. So this red color is identify there is the change, and white color is identify there is the no change. Okay. So now I want to calculate it. Each area, suppose in 1991 water body, how much water body in year of 2021? So in build up area 1991, how much build up area we can got in year of 2021? So how much vegetation we can got in 2021? How much others feature we can got in the 2021? This type of analysis we can calculate it, and this area is also called the transition area. So in this time, we try to show you that part, how you can easily calculate it, the transition area. So for that, first of all, we need to multiply the before image with 100 and add the after image. Okay. And now we can just showing the result so that we can multiply with that. Suppose I can simply take a variable. Suppose put the variable name is that merged, and then I simply call this before classes and paste here. This before class is multiply with after class, and then it will also add it will be after multiple with 100 and add with upper class. Okay, so this is the formula we need to put in here. So before class is that, what is the before? Before class is the 1991, and what is the after? After is the 2021. So before class I multiply with 100 and add with after class, and after that I can simply put the rename as a transitions. So in this time what happened, you can see in this time, mainly in this time, we multiply the before image with 100 and add with after image. Okay, just we simply multiply 100 and then add with after class and put the name rename. In this time, the resulting pixel value will be unique, and we will represent each unique transition area, such as in this time 102 is urban to bare. So in this time you can see, in this time, suppose I can get the result in here look like this. Suppose I also write this comment. Suppose I can put the result look like this. Suppose this is the 102. In this time, what is the 1? 1 is the water, and what is the 2? 2 is the build-up area. So it means that water to build up. Suppose you can get the result look like this. Suppose 302. What is the meaning? What is the 3? 3 means that you can see 1, 2, 3 vegetation, and what is the 2? 2 is the build-up area. So we can say that vegetation to build up. Okay. Suppose I can get the result look like this, such as 202. What is the meaning? It means that build up to build up. Okay. So in this time, what is the water? This water is before class, means that 1991, and this build up is that after class. It means that year of 2021. So in this time, I can simply multiply before class with 100 and we add with after class and rename the transition. And because in this time when I multiply with this value, then I can get the result look like this: 102, 202, 302. All of this transition I can easily get in here. Okay. So in this time, I also try to need to calculate the frequency histogram to get a pixel count per class. So in this time, I need to calculate the pixel count per class. Per class, how many pixel is available? I need to calculate. And for calculating this, I used here the frequency histogram. Okay. So let's go. How can I do that? So I simply take a variable. Suppose this variable name is that transition matrix. You can use any variable name and call the merged and use the function. This function is the reduce region. Okay, and put all of the argument one by one. So just I simply make a dictionary in here, curly bracket start, and also curly bracket int. And then first of all, reducer. In this time I want to calculate the pixel count per class. So for that I need to use here the frequency histogram. So use here the ee dot reducer dot frequency histogram. Mainly it calculated the pixel count per class. How many pixel is available for the per class? It will be calculated. And then we also need to put at the geometry. So in the geometry is our shapefile variable name is that. You can check the shapefile variable name is that AOI. So just put at the AOI. Then scale. Scale is the resolution of your satellite image. For Landsat 30-meter resolution. Okay, and it's not I simply remove it. It's not for this time. I simply remove it. Okay, so now we just print that. So this print number of pixel for each class transition. So now we just simply print this. So simply use the print function. Print this transition matrix. Simply copy and paste, and we can get it from this transition. what is, we can see, I also put rename that transition. Simply copy and paste. Okay, now let's check the result about the transition. We can calculate it, the pixel count per class. Okay, they're working. It's calculating this result. So count per pixel. Okay, it's working. Okay, so in this time we can see we can get the result look like this. So total 14 class. I simply click on here. In this time we can see 101, 104, 201, 202, 203, 204. In this time 101, what is the meaning? 10 means that 1 is that water body, water body to water. So water to water, how much pixel we can get? Water to water. Then 104, what is the meaning? Water to others, how much pixel we can get? 2. 201, 201. What is the 201? 2 is the build up area and 1 is that water. So build up area to water. 202. So build up area to build up area. 203. So vegetation to build up area. So same process. 101. So 1 is that before. Before means that year of 1991 and 2 means that after. After is that year of 2021. Okay. So we can calculate it all of those pixel count per pixel. How much pixel we can get the result in here. So pixel for each class we can get. Okay. Okay. So now if you want to calculate the area of each class transition, then we can easily do that using the reducer function, and also we can easily get the result in square kilometer, how much area will be convert. Okay, so this in this time it only showing the pixel count per pixel. Okay, so now I want to use this and also try to calculate it. So water, how much area will be convert into the water body, how much transition zone will be converted into the water body, how much build-up area will be converted into the water body. Okay, so this type of analysis we can easily do that, and also calculated this transition area. Okay, so this is in this time it's showing only for the pixel count per pixel of each classes. So let's go. In this time we try to show you this. So for that I can simply take a variable. Suppose this variable is that suppose area image, and then use a function earth engine image dot pixel area. So mainly we are using this function for calculating the area, and now we can get the result in square meter. But when I want to divide with 1 million, then I can get the result square kilometer. So just simply put the 1e6, I can get the square kilometer. Okay, and then I simply use the add bands function and call this merged. Okay, so simply copy and paste. Okay, so after that we can calculate it, this result. So in this time we need to use the group reducer. So for that we can simply take a variable, suppose area, and use this, call the area image and paste and use a function, this function called the reduce. I put here the function for the reduce region. So I guess we will put here this all of the arguments step by one step, then we can easily calculate the area. Okay, so in this time, if you have any question, you can ask me. Or any doubt about this transition area or transition zone. Have any question? Okay, can you hear me now?
Yes, I can
Hello?
hear you.
Yeah. So any question, if you have any question or any doubt?
Yes, I have one question here.
Yeah, please.
The transition is the same process when we make in GIS, ArcGIS, that we discover the difference between two images in two times.
Okay, so in this time, you can also export this image. Suppose you can also export this image from here and also perform the analysis in the ArcMap software for make the change detection. Okay, so I have also recorded this video class also. So I also provide you this video recorded class. Then I hope you can easily download the TIP images from here. For the 2 time pro TIP image you can download and apply this same process in the ArcMap software. I hope you can easily get the change detection map also. So in this time, I show you that only for the Google Earth Engine platform, how you can easily perform the analysis.
Yes.
Okay. So I have the classes already recorded this class for the ArcMap software. So I also send you the video recorded so that I hope you can easily practice, and also you can simply download the TIP images from here for the different 2 time period, and you can easily perform using the ArcMap software, make the change detection map. Okay. Then I hope it will be covered. Okay, so now I just try to show you this how you can easily calculate the area of each classes.